Part A, Basic Setup. Attach the temperature probe to channel 1 of your LabQuest device. Ensure that your LabQuest device connects to the correct temperature probe by clicking Sensor, and in channel 1, choose the sensor for Temperature Direct Connect Temp, then click OK, and then OK again. A temperature should now be visible. Change the parameters of the experiment for the rate to be 12 and the duration 300 seconds. Adjust the graph options for the y-axis to have a top value of 90 and a bottom value of 20. Part B, Reaction 1. Measure out approximately 95 to 100 milliliters of deionized water. Measure the mass of this water in a coffee cup calorimeter on an analytical scale. Be sure to measure or record the mass of the water to 4 decimal places in your lab manual. Next, on an analytical scale, measure somewhere between 2 and 2.2 grams of solid sodium hydroxide. Be sure to report to 4 decimal places in your lab manual. Press play on the LabQuest device, insert the temperature probe in the water of the calorimeter, and then record the data or initial temperature for the first 10 to 15 seconds. Add your solid sodium hydroxide to the solution and then continue stirring and collecting data for the next 300 seconds. Part C, Reaction 2. Measure out approximately 100 milliliters of 0.5 molar HCl solution. Pour this solution into a tared coffee cup calorimeter and then measure the mass of this solution on your analytical scale. Be sure to record the mass to 4 decimal places in your lab manual. Next, on an analytical scale, measure somewhere between 2 and 2.2 grams of solid sodium hydroxide. Be sure to report to 4 decimal places in your lab manual. Before starting Run 2, save your Run 1 by clicking the file cabinet in the top right-hand corner on the LabQuest device. Next, insert your temperature probe, press the Play or Collect button on the LabQuest device, and record a baseline value of temperature for the next 10 to 15 seconds. Now add your solid sodium hydroxide to the solution and continue stirring and collecting data for the next 300 seconds. Save this run by clicking the File cabinet before moving on to the next reaction. Part D, Reaction 3. Measure out 50 milliliters of 1.0 molar HCl solution. Measure the mass of this solution on an analytical scale and record in your lab manual the mass to 4 decimal places. Measure out 50 milliliters of 1.0 molar solution of sodium hydroxide. Measure the mass of this solution on an analytical scale and record the mass to 4 decimal places in your lab manual. Pour the 50 milliliters of your 1.0 molar HCl solution into your coffee cup calorimeter. Insert the temperature probe and then press Collect or Play on your LabQuest 2 device. Allow the device to collect data for 10 to 15 seconds and then add your 50 milliliters of 1.0 molar sodium hydroxide solution. Continue collecting data for the next 300 seconds. Upon reaction completions, you will need to save the data. Insert your thumb drive into the USB port. Then on the top right corner, click Run 3, choose All Runs to show all curves simultaneously. Click File, Save, name your document appropriately, and then click Save. In parts E through G, you're going to continue to process the data and perform several calculations. These include determining the delta T for each reaction, calculating the percent error between the experimental value and accepted value, and then exporting a graph that has been annotated of all of your curves. Using Logger Lite, open the file attached for the Hess's Law experiment. Using your cursor, highlight all of the data, then click the Stats button and choose Runs 1 through 3, and click OK. A box will show up with data for each run, and you will use the max and min temperature values for further calculations. All calculations should be shown in the space provided in your lab manual. However, I have created an Excel document that performs all of these calculations that you can use for comparison to your data. First, you want to take the data from run 1 and put the max and min temperature values, then for run 2, and then lastly for run 3. Once these values have been transferred from the Logger Lite program to your Excel document, you can then calculate the delta T, or final minus initial temperature values for each run. Note the masses of reagents A, B, and total mass are just arbitrary values and are not indicative of the experiment shown in this video. Next, you want to calculate the amount of heat produced in each reaction. This is the value Q. You want to multiply the delta T times the total mass times the specific heat for each run. The enthalpy, or delta H, for each of these reactions are equal to the amount of heat produced in each reaction. Next, you want to calculate the number of moles of sodium hydroxide. For runs 1 and 2, you used a solid form of sodium hydroxide, and you will divide that mass by its molar mass of 40.00 grams per mole. This will provide the moles of sodium hydroxide. However, for run 3, you have 50 milliliters of 1.00 molar. So convert that milliliters to liters, then multiply that times the molar concentration, and that will give you moles. Lastly, you want to determine the enthalpy per moles of sodium hydroxide. Use the enthalpy delta H for each run and divide by the number of moles of sodium hydroxide to determine this value. At this point, you want to determine the percent error of your experiment. Determine the experimental value, which is the sum of runs 1 and 3, and the accepted value, the value of run 2. The percent error can be calculated as the absolute value of the experimental minus the accepted value divided by the accepted value times 100. Next, finish processing any of the collected data and complete all calculations. Be sure to answer all post-lab questions and then submit the following on Blackboard.